Hello students, this is Shaji Tanan. Welcome back to my channel Crack Chemistry. Today I am here with the class 8 topic. The name of the topic is Chemical Effects of Electric Current Part 1. Student, this is a very important topic for you because the same topic you will study in detail in class 10th as well as in class 12. So you can understand how important it is for you to have a thorough knowledge of each and every concepts of this chapter. Students, in this video I have explained each and every topic with the help of interesting activities and little bit extra knowledge I have given to you, which will be very helpful for you in making your concepts strong. So now, before starting, I just want to remind you to subscribe my channel for getting information about further important uploads. Press the like button if you like this video and share this video with your friends. So now let's see what we will study today. Students, first of all, we will study about conductors and insulators. After that, we will study the conductivity of water and other liquids. Then we will study the chemical effects of electric current. And these two topics, electroplatings and application, we will study in my next video, chemical effects of electric current, part 2. So, now we are going to start our discussion. Students, all of you know that electricity plays a very important role in our life. So, and it is difficult to spend even a single day without electricity because you know that most of our appliances run on electricity like TV, ACs, fridge, and even for charging your mobile, laptops and computer you need electricity. So now you will agree that it is difficult for us to spend even a single day without electricity. So now definitely you must be appreciating the role of electricity in our daily life. So if you appreciate electricity, so definitely being a curious student, you must be thinking what is electricity. You must be curious to have some information about electricity. So we are going to get some more information about electricity. All of you know that it is dangerous to touch an electrical appliance with wet hands. What is the reason for this? Water has dissolved minerals in it, which are good for health, but make water conducting. These minerals make water conducting. So now you must understood that why it is dangerous to touch an electrical appliance with wet hands. Now we will also discuss about how the electric current flows from one place to other and how it passes through a liquid. So first we will discuss about conductors and insulators. Students, electrical conductivity of a substance is the measure of its ability to carry electric current. So on the basis of their electrical conductivities, materials can be classified as. First category is the good conductors of electricity. So these are the materials which allow electric current to pass through them easily. They are called as good conductors, or simply we call them as conductors. And the examples of most of the metals like copper, aluminium, silver, gold, etc. So most of the metals are good conductors of electricity and their conductivities are temperature dependent. So as the temperature increases, conductivity of these metals decreases and vice versa. So I hope this point is clear to you. Now, how can we test whether a substance is a conductor or not? We can test the conductivity of a substance, whether it is a conductor or not, with the help of a tester. So in this diagram, you can see this is a simple tester you can see that one of the terminal of the tester is connected to a bulb and the other end is connected to a wire whose other end is free. Similarly, the other end of the bulb is also connected to a wire. So, the substance to be tested can be placed in between these two wires. Substance to be tested, if it is placed in between these two wires, what will happen? If it is a conductor, the bulb will glow. If it is not a conductor, the bulb will not glow. So this is a simple tester which is used to test whether a substance is conductor or not. So with the help of this diagram, you can see that we have taken a screwdriver which consists of both the parts, metallic part and non-metallic part. So once we have placed this metallic part between the two ends of the tester, the bulb glows. It indicates that it is a good conductor. Now, contrary to good conductors of electricity, there is other category which is called as poor conductors of electricity. So students, as the name indicates, poor conductors are those substances which do not allow electric current to pass through them easily. They are also called as insulators. They are also called as poor conductors or bad conductors of electricity. So examples are wood, plastic, glass, vegetable oil, distilled water, etc. Then again with the help of same tester we can test whether a substance is a conductor or a poor conductor. Now we can see that the same screwdriver we have taken. This time what is placed between the free ends of the tester? We have placed the substance which is made up of a plastic. So in this case the bulb won't glow. With the help of this simple tester we can check the conductivity of a substance. So one more point I would like to mention here. This is the same tester which I was discussing about in my previous slide. You can see here these are the two free ends of the tester. So in between these two free ends of the tester, what is present? You can see that air is present between the two free ends of the tester. And as the air is a poor conductor, so what will happen? Because of the poor conductivity of air, this bulb will not glow. So now we can see that, we can conclude that air is a poor conductor of electricity. But at the same time, all of you must have realized that during thundering, the electricity passes through air only. So now we can say that we strictly cannot say that a substance is not a conductor, because under certain conditions the same material can conduct the electricity also. So now we have to say that it is preferable to classify materials as a good conductors and poor conductors, instead of classifying them as conductors or insulators, because under certain conditions most of the materials can conduct electricity. We have seen air as an example just now. So I hope it is clear to you. Now the third category is of semiconductors. So what are semiconductors? Semiconductors are the materials that can neither be classified as good conductors nor as poor conductors of electricity. For example, silicon and germanium. So what about their conductivity? Their conductivity lies between good conductors and poor conductors of electricity. So I hope all these points are clear to you. Now we will discuss about conductivity of water and other liquids. Children, all liquids do not conduct electric current. Most of the liquids that conduct electricity are solutions of acids, bases and salts. So how can we test whether a liquid allows electric current to pass or not? We can use the same tester. But what we have to do, we have to replace the cell by a battery. But before using the tester, we have to check whether it is working or not. So how you can check whether it is working or not? Students, what you will do, join the free ends of the tester for a moment. If it is working, the bulb will glow. If it is not working, the bulb will not glow. So what is the reason if bulb doesn't glow? There may be few reasons. One of the reason can be the cells are used up. Another reason can be the connections are loose or the bulb is fused. So what you will do? You have to check all these situations one by one. First, you can check whether the connections are loose or not. If connections are not loose, then you have to check the bulb. If after replacing the bulb, still it is not glowing, then you can think that the cells are used up. You replace your cells. You can use the same tester so we can understand the conductivity of different liquids with the help of this activity. Students, you can see here that one of the end of the bulb is connected to a wire and the other end of the wire is immersed in a liquid to which we are going to test. Suppose it is lemon juice, so or any other testing solution you can keep here. So suppose I have taken here lemon juice. So what we have done, one end of the bulb is connected to the negative terminal of the battery and the other end is connected to a wire and the other end of that wire is immersed in a solution to be tested. And similarly, the positive end of the battery is connected to the other wire and the other end of the wire again is immersed in the solution to be tested. So in case if the solution is conducting, if the liquid is conducting, the bulb will glow. If the liquid is not conducting, the bulb will not glow. So I hope it is clear to you. The same diagram it is shown here. We have taken a battery and the connection just now I have explained you that this is the activity which I have explained you just now. So now this activity shows that some of the liquids are conducting and some of the liquids are not conducting. We can repeat this activity with the help of different samples of liquids and we can see that if we have taken tap water, so we know that tap water is a good conductor because tap water conduct electricity. So I am writing here it is a good conductor. Now lemon juice is also a good conductor. Soap solution is also a good conductor. Salt solution is also a good conductor. Seawater is also a good conductor. Vinegar is also a good conductor. So all these solutions, all these liquids which we have discussed just now, they are the good conductor of electricity. Now we are coming to kerosene. Kerosene is a poor conductor of electricity. So this is a poor conductor. Then distilled water. Distilled water is again a poor conductor of electricity. Vegetable oil is a poor conductor. Coconut oil is a poor conductor. Sugar solution is a poor conductor. Honey is a poor conductor and petrol is also a poor conductor. So now we have discussed this activity and children remember that the bulb glows when the electric current passes through it. What is the reason why the bulb glows? The reason is the heating effect of the current. The filament of the bulb gets heated to a high temperature and it starts glowing. So when the current in the circuit is weak, then the filament doesn't get heated sufficiently and it will not glow. So in such case, we have to replace the bulb in the circuit by an LED. We have to take LED. So now we will discuss about LED. What is LED? LED is the light emitting diode. It is a semiconductor diode that emits light when an electric current is passed through it. Where it is used? It is used in mobiles, computers, TV, etc. And there are two wires which are called as leads attached to an LED. One lead is slightly longer than the other. So while connecting to the circuit, longer lead is always connected to the positive terminal of the battery. Students, you have to keep this point in your mind. Then the shorter lead is connected to the negative terminal of the battery. And one important thing is that the LED glows even when a weak electric current flows through it. Electric current is weak, the bulb will not glow, but in that case we can replace the electric bulb with the help of LED. So here you can see these are some pictures of the LEDs. As we have seen that these are the leads, a longer one and a shorter one we have discussed just now. This is another image of LED. Now we have a question based on the discussion. Does pure water conduct electric current? You know that pure water doesn't conduct electric current. So no. Pure water doesn't conduct electric current. If not, what can be done to make it conducting? How it can be made conducting? You can add some acid in it, you can add some minerals in it, or you can add some base in it. So, by adding some minerals, it can be made conducting. By adding some minerals. It can be made conducting by adding some minerals. So we are going to discuss one more activity. All of you are familiar with magnetic needle. A magnetic needle will deflect if an electric current passes through a wire kept nearby. And even if the current is small, the deflection of the needle can be seen. So I just want to share this circuit with you. Here you can see that we have placed a magnetic needle inside the discarded matchbox. So this is the discarded matchbox. In the discarded matchbox, we have placed a magnetic needle, and this is a conducting wire which is wrapped around a magnetic needle. So what we can take here, in the same way as we have discussed the activity just now, we can take the testing solution. We have taken the testing solution inside this beaker. So what will happen if the solution is conducting? You can find the deflection in the magnetic needle. So this is also one more tester. So students, we are going to discuss another very interesting activity here. So with the help of this activity, we can check the positive terminal of the battery. So what is this activity? With the help of this diagram, we can see we have taken a tester and we have taken a potato which is cut into two halves. So one half of the potato is placed here, and in this potato, two ends of this tester have been inserted. Around after half an hour, you will find some greenish blue colored spot to one end of the tester. And once you repeat the same activity uh, with different fruits and vegetables, always you will find a greenish blue spot nearer to one end of the tester, but the other end will remain clear. So what does it mean? Don't you find it is interesting? So once this experiment is repeated several times, and it was found that the greenish blue colored spot appears only to that wire which was connected to positive terminal of the battery. So with the help of this experiment, we can test the positive terminal of the battery. So one more point I would like to mention here. Students, when an LED is connected to a conducting wire, or a conducting wire is wrapped around a magnetic needle, can act as a tester to detect weak electric current. So this point we have discussed in detail also. Name some substances which are good conductors of electricity. So students, just now we have discussed many substances which are good conductor of electricity, like we can write here aluminium. Just now we have seen Al, gold is Au, silver is Ag, and there are many other metals. They all are the good conductors of electricity. Apart from that, we have seen salt solution was also a good conductor of electricity. We have seen tap water. Tap water was also a good conductor of electricity. So there are many substances which conduct electricity through them. So now students, we will see what are the topics we have discussed. We have discussed about conductors and insulators. After that, we have discussed the conductivity of water and other liquids. Then we have seen chemical effects of electric current. And as I told you that electroplating and applications I'll discuss in my next video, chemical effects of electric current part 2. So don't forget to watch this video part 2. So students, thank you so much for watching this video. Don't forget to subscribe my channel. Press the like button in case if you like it, and share this video with your friends. Thank you so much. Have a nice day.